Today we're starting 2.6, solving compound inequalities. The inequalities we've dealt so far have been fairly simple. Now we're going to be dealing with a couple that are called compound inequalities. They're going to be dealing with the statements that have the words and or. That makes them compound inequalities. Here's the chart. If I have numbers, all real numbers that are greater than 2 and less than 6. So this means every number that are greater than 2 and less than 6. You can say it like this, but it is written like this. 2 is less than x is less than 6. Graphically, it's an open circle at 2, open circle at 6, and they connect. All real numbers greater than or equal to 2 and less than or equal to 6. The only difference between those two is now it includes both of those numbers. So now it has the lines underneath. So now we have the solid dots on our graphs, and they connect. So that means 2.5, 2.35, 3.5, 4.5, 5.5. All the decimals, all the fractions, every single number in between is there. All real numbers less than 2 or greater than 6. With the thing or, it has to be one or the other. So give me a number that's less than 2 or greater than 6. Give me a number that, what's that? 10. It's greater than 6. That's true. Give me a number that's less than 2 or greater than 6. 0. 0 is less than 2. Give me a number that's neither. 5, 4, 3. Those numbers are neither because it doesn't fit. Anything that's in between here does not work. Or statements, it has to be one or the other. All and statements are going to connect, or statements are going to go opposite directions. All right, the free chlorine in a pool should be between 1 and 3 parts per million inclusive. Write a compound inequality to show the levels that are within this range and graph the solutions. Everyone's been swimming. You have to keep the chlorine of a pool in a certain range. If you don't keep the chlorine in a pool within a certain range, things start to happen. If you don't have enough chlorine in a pool, do you know what happens? It starts changing colors. It gets green. Algae starts to grow. It's bacteria. If you have too much chlorine, you get that chlorine smell, that bleach smell. You can get chemical burn if you have way too much. Like if you go to hotels, you get that smell. But if you go to a normal house pool, you shouldn't smell anything. But a hotel pool, they usually jack up the chemicals because they have to kill all germs. But a house pool, you want it just stabilized. But if you don't keep up on your pool chemicals, it starts changing colors. And it has to stay within a certain range. So it has to stay in between 1 and 3 parts per million. How could we write this as an inequality? A compound inequality. What's the lowest? Is this an and or an or? And, because it has to stay between. So the lowest is 1, and the highest is 3. And since it has to stay in between, the nicest thing about an and statement, they go like this, Could it be 1? Inclusive. The word inclusive has that one prefix, in. So it includes it. There you go. 1 is less than or equal to x is less than or equal to 3. To graph this, we'll graph the 1, we'll graph the 3. Open or close dot? Closed, open or close dot. And then they're going to connect. It looks scarier than it actually was. When we actually solve compound inequalities algebraically, I have -5 is less than x plus 1 is less than 2. I'm going to show you the easiest way to do this problem. I can take this and break it into 2 problems, or I can leave it into 1. I'm going to leave this in the 1 problem. I want to get x by itself in the middle. So what's in the middle with that x? 1. What's happening with that 1? Or with that x? It's adding 1. How do I get rid of an add 1? Subtract 1. But I just don't have one side of the problem. I have 2 sides. So I have to subtract 1 to both sides. So -5 and a -6. Or sorry, -5 and a -1 is -6. Less than x gone. Less than 2 minus 1 is. And there you go. Now to graph it. -6, 1, open or closed? Open or closed? Since it's the and, we're going to connect it. Why don't you give this one a try? All right, coming around, there's a good bit of you that have this correct. What do I need to do first? Add 1 to every side. So you add it to the left side, you add it to the right side. What's 8 plus 1? 9. Less than 3x is less than 12. Sorry, I forgot my equal. Now I divide by 3. Now I divide by 3 here, divide by 3 here, divide by 3 here. 9 divided by 3, 3. Less than x, less than or equal to 4. Now when I graph, here's a 3, here's my 4. My 3 is open, my 4 is closed, and they connect. First thing we need to do, subtract 5. Subtract 5, subtract 5. -4 and -5 is -9, less than or equal to 3n, less than 6. Divided by 3, divide by 3, divide by 3. -3, less than or equal to n, less than 2. Don't always think you're going to get nice and neat whole numbers. If you get a fraction, leave it as a fraction. Don't try to change it to a decimal, change it to a mixed number, just leave the fraction as a fraction.
This way they go to the way you graph it different. Like let's say
Now, the way it should also probably go is the small number should always be on the left, the big number should always be on the right. If you did it correctly, that's the way it should be. This one is closed, this one's open, and they connect. That's it. Now the question that was brought up, what if this was a negative here? And this is a great question. We still subtract 5, subtract 5. We still get the negative 9. I erased too much. I don't know why I did that. 6. Still divide. Negative 3, negative 3, negative 3. Now, I get 3, this flips, and this flips. I know, I made a mistake when I was going too quick. That happens. Negative 2. What happened is, when I divided by a negative, those symbols flipped. Now, in order to make the problem look better, so it went from small number to big number, I'm going to take this entire problem and flip it. You know how we usually flip it so it's the variables first? I'm going to flip the entire problem. So negative 2 less than n less than or equal to 3. That's all I'm going to do. And now I just graph it like normal. But that is a great question. Because I think I didn't put one on here because I wasn't sure if the book had one like this in there. I flipped it so I had small to big. So when I did graph, it's negative 2, 3. Because a common mistake will be, you get in the habit of doing this. And when you see the keystones, you're going to do that, and it's going to be marked wrong. Graphically, that is incorrect. We've been working with the ands. This is an or. The great thing about or statements, you just do both problems.
Can I go to a separate one?
You just graph, do both problems. Watch. Don't even worry about it. It's like 2 separate problems. What do I have to do here? Subtract 8, subtract 8. T greater than or equal to negative 1. Subtract 8, subtract 8. T is less than negative 6. On my number line, which one is my smaller number? Now I got to think. That's the only problem here. Which one's a smaller number? Negative 6. Negative 6 my smaller number. Negative 1's my bigger number. Negative 6 is open or closed? Open, it goes to the left. Negative 1 is closed, and it goes to right. It's less than, and it goes to. You got to you got to look at which one's the smaller, which one's the bigger. And that's it. You do 2 problems, you graph both problems, but you have to pay attention to which one's smaller, which one's bigger when you graph. They're technically the same, but you got to be a little bit careful on the ors of which one, on the placing of the graphing. Ors are easier to solve because you just do the problems. Ors you have to be careful on the graphing aspect because you got to pay attention to which one goes first. Try this one. What do I have to do on the left-hand side? Divide by 4. What do I get? Less than or equal to 5. On the right, I have to divide by 3. Greater than 7. For my number line, which one's my smaller number? 5. My large one has to be 7 then. My 5 is closed, and it is left. My 7 is open, and it is to the right,